Hi and Assalamualaikum. It's me again, Madam Zahira. So how is it going for chapter 1 and chapter 2 so far? Are you guys doing well so far? Let me tell you the best part for chapter 3. Chapter 3, periodic table, is not included in paper 2 PSPM, but it will be assigned as your assignment of SK015. So let's move on to the first subtopic of chapter 3, which is classification of elements. So at the end of 3.1, you should be able to describe period, group, and block of SPGF. Deduce the position of elements from its electronic configuration. Okay, so now let's learn how to describe period, group, and block of SPGF. Okay, so you're already familiar with this powerful table. So what is the importance of periodic table? So in periodic table, elements are classed according to its arrangement of electrons. Hence, it is convenient for us chemists to predict the chemical and physical properties of elements based on their position. Hence, we could determine the physical properties and the chemical properties, which is either the element exists as metal, non-metals, and metalloids. As the learning outcome said, that we can determine the period, block, and group of each element by referring to its electronic configuration. For example, we have sodium. Sodium with the proton number, so Z, again, I remind you, Z is the proton number. Of 11. So, this is the electronic configuration of sodium. Okay. So we're gonna fill it according to the rules that you have learned back in chapter 2. Okay. So look at the valence, look at the outermost electron of sodium, which is 3s1. Okay, so from 3s1, we can determine the period, which is the highest number of n of 3. So the period is the highest number of shell. Okay, the group, you just refer it to the outermost electron. For block as element, we can say that as refer to its valence electron. And for the block, so sodium is in S block. So before we learn how to determine all the period, block, and group of each element, we must know how to categorize the elements in electronic configuration, which is for S, P, and D elements. So there are three categories of electrons. The inner electron. Inner electron is the electron in the inner shells or core electron. Okay. In short, it is the electron in the shells between nucleus and outer shells. Outer electron is the electrons in the highest energy level or the outermost shell. For the valence electron, well, it differs according to block. So for block S and P, the outer electron is just the same as valence electron. Okay, just like we did for sodium. But for the transition element or block D, the outer electron is not the valence electron, and I'll explain afterwards. So there are 4 blocks in periodic table. The first one, the S block, which is group 1 and 2. So this is the the block S. Block P, it is from group 13 to 18. So this is from group 13 to 18. Yeah, so this is block P. And block D is from group 3 to 12. So this whole thing in blue is block D. And the last block at the bottom of periodic table is block F. So take a look back at the electronic configuration of sodium. Okay, we're gonna categorize all the 3 categories of electrons. So the inner electron is 1s2, 2s2, and 2p6. Okay, so the electron, if the question asks you how many inner electrons are there in sodium, you just need to total up the number 2 plus 2 plus 6, which is equal to 10 electrons. For the valence electron, since sodium is in S block, hence valence electron is the same as outer electron. So the valence electron for sodium is 1 and the outer electron is 1 as well. For nitrogen, which is in block P, the electron configuration would be 1s2, 2s2, and 2p3. Okay. Please make some correction on your study guide. Okay. Because 3 plus 2 would made up to 7 proton number. So now let's determine the inner electron, outer electron, and valence electron. So 1s2 would be the inner electron of 2 electrons. The valence and the outer electron would be the same, which is 2s2 and 2p3. Since both are in the highest end, so that would be 3 plus 2 would be 5 electrons. For block D element, the inner electron consists of all proton numbers, not including the outer electron. So for the inner electron, that would be 6 times 6 plus 2 plus 6 plus 2 plus 2 would be 18 plus, okay, so 3d6, it is not in highest end, so it must be considered as inner electron as well. So 18 plus 6, that would be 24 electron. The valence electron for block D is quite special because you need to consider the last 2 orbitals. Okay, so the last 2 orbitals is 4s2 and 3d6. So the valence electron would be 6 plus 2 equal to 8 electron. But for the outer electron, again look for highest end. Okay, so that would be 2 electron.